In this lesson, we are going to define atomic and mass numbers, as well as determine the number of protons, neutrons, and electrons in an atom. Atoms are composed of three types of subatomic particles: protons, neutrons, and electrons. Let's look at an example for the element beryllium. So this shows what you might see if you looked at the element on the periodic table. Note that periodic tables will arrange numbers in different ways, but you'll see the same basic information. The whole number for the element represents the atomic number. Notice that the elements are arranged in order of increasing atomic number on the periodic table. The atomic number also tells us the number of protons we have. So the atomic number for beryllium is 4, so each atom of beryllium has 4 protons. If we change the number of protons, we change the identity of the atom. So what is the atomic number of fluorine? We see that fluorine has an atomic number of 9 based on information from the periodic table. How many protons are in an atom of fluorine? The answer to this is also 9. The atomic number gives us the number of protons. If we change the number of protons, we change the identity of the atom. Another way of representing the information given on the periodic table is with what's known as the isotopic symbol. It shows the chemical symbol for the element, and it shows the atomic number at the bottom, which in this case is 4, and it shows the mass number at the top. Both of these numbers are shown to the left of the chemical symbol. Both of these are shown to the left of the chemical symbol. In the isotopic symbol, we show the mass number as a whole number. When you look at the periodic table, you'll notice that it's not a whole number. This is for a specific version of that atom. We'll talk more about how we get to that non-whole number that's shown on the periodic table later. Based on the isotopic symbol, we know the mass number and the atomic number, and that also allows us to figure out the number of neutrons, because the mass number is equal to the number of protons plus neutrons. In this case, we know that the number of protons plus neutrons is equal to 9. We know that we have 4 protons because the atomic number is 4, and we can therefore solve and find that n equals 5, so that an atom of beryllium-9 has 5 neutrons. What is the mass number of the given isotope? The mass number is 15. In the isotopic symbol, the mass number is always given at the top. How many neutrons are in the given isotope? So we know the atomic number, which is at the bottom, in this case it's 7, and this tells us the number of protons that we have. We also know that protons plus neutrons equals the mass number, which is 15 in this case. So 7 plus n equals 15. So we get a value of n equal to 8 for the number of neutrons. We know how to identify the number of protons and neutrons in a particular isotope of an element. Now we need to look at electrons, which are the third subatomic particle that make up an atom. In this case, we look at our protons, which we have 4 because we know our atomic number is 4. For neutrons, we know 4 plus n is going to be equal to 9, so n equals 5. And for a neutral atom, so one that's not charged, we have an equal number of protons and electrons. So we have 4 protons, we have 4 electrons. Note that this is only true for neutral atoms. We know this is a neutral atom because there's no charge shown. When we start looking at ions, we'll see that a charge will be given up in the upper right corner. If there's no information there, then we know that it is a neutral atom. How many electrons are in the given isotope? Just a reminder, this is a neutral atom because we do not see a charge. So for protons, we have 7 because our atomic number is 7. For electrons, because this is a neutral atom, we would also have 7 electrons.